Hello and welcome. I just started this live thing so that people get the email that it's starting. We'll give it another 5 minutes and then we'll begin, just so people have time to notice the notification and jump in the stream. So I'll be right back. Okay, we're back. Welcome to the introduction to Moonbeam hands-on. So we are going to be going through a relatively new project, Moonbeam, which is kind of an Ethereum clone on Substrate. So it's a chain that supports all the Ethereum RPCs, all the endpoints that applications and users might be used to from the Ethereum world. All the wallets, all the tools, everything supported, and of course the EVM, so that you can run basically unmodified Solidity contracts. We're going to be playing with that today. There was an introduction a few weeks ago. You can find it in the archive of this Crowdcast channel, so just look at past Crowdcasts. In this one, we are going to be going through some Solidity code that I wrote a while back. We're going to be building a charity raffle, and you can follow along with this if you are interested. It's really easy stuff. You can just type after me and I'll explain every line. If you get stuck on anything, let me know in the chat. I'm keeping an eye on it, and I'll just scroll back up and tell you what's what and help you get that thing in. The major difference from the previous Crowdcast is that we now have a live testnet, public live testnet for Moonbeam, and that's called Moonbase Alpha. They're all about cool names. So we can test this stuff on a live network actually, and if you join their Discord, you can request glimmers or moonies or whatever you want to call them, the tokens. They are denominated in dev right now, so you can request dev tokens on their Discord from the Faucet bot. You can get 10 dev tokens, and that's like 10 ether worth of gas fees basically. So that'll let you deploy quite a few contracts, and that's what we are going to do. Why does Moonbeam exist? Well, as you might know, Ethereum is in a bit of a problem with transaction fees and the network being clogged. This is great for everybody who likes Ethereum. I like Ethereum, but it's not that great for users. You don't want to have to pay $20 to extract your money out of a DeFi protocol that you're using to earn interest, which is far smaller than the fee you need to extract it out. They're not exactly close to any layer 2 solutions being production ready enough to alleviate that load, and Ethereum 2.0 is not really even on the horizon in terms of being useful. So it's very difficult to see how they could alleviate this in a very short time frame. And Moonbeam is here for two reasons. One is to help people use another network that might that can provide them with the same infrastructure as they have on Ethereum, but with frankly just less traffic, right? It's not that clogged. The other selling point is that Moonbeam is based on Substrate, and Substrate is a framework which is the basis for Polkadot, Kusama, and a lot of other chains that will and will not become parachains on the Polkadot and Kusama networks. So it's a battle-tested foundation on which you can build interesting new stuff, and this will allow for some very interesting optimizations down the line, possibly speeding up Moonbeam way past what Ethereum can do right now, especially because it's proof of stake from the get-go, right? Ethereum 1 is proof of work right now, and Ethereum 2 will be proof of stake, but that transition is not going to happen for a while. And Moonbeam started with proof of stake, which means it has the potential to be much more efficient and faster than Ethereum to begin with, which would translate to more scalability on layer 1 in some ways. But we're not there yet. We'll see how the tests perform and so on. Additionally, because it's based on Substrate, it's compatible with a certain plugin that's called Cumulus, which will allow any chain that's based on Substrate to connect to Kusama or Polkadot as a parachain. And that means that this version of Ethereum will have instant interoperability with any other chain connected to Polkadot. and that's a huge advantage. So not only do you get a faster Ethereum, you get a faster Ethereum that's connected to a bunch of other chains out of the box. And this is not a competition with Ethereum. This is a scaling solution in a way. It is not difficult to make a bridge which would mint tokens on Moonbeam and burn and lock them on Ethereum and vice versa. So you can have an atomic bridge that could move tokens from Ethereum to Moonbeam. It's just one more way of helping Ethereum scale and communicate with other chains, but it's also its own ecosystem, which hopes to get a lot of adoption and a lot of interesting use cases. So, like I said, Moonbase Alpha is their public testnet, and that's what we're going to be connecting to in this guide. You can go to docs.moonbeam.network, but let me just check some questions. I see some have already come in from Tomasz. There are validators in Moonbeam network. So there will be validators, yes. There will be validators in Moonbeam network. There are none right now. The public testnet is just a deployment of a parachain, of a relay chain and some parachains. So it follows the Rococo model. It's configured like a parachain testnet. And Moonbeam is one of the parachains on this testnet that they've developed. So Moonbase Alpha is configured as a parachain already. This is so they can test how being a parachain might affect such a chain in the beginning. So they didn't want to go the standalone route like substrate only. They wanted to go all in straight to the parachain mode so that they can see what implications they can expect. But yes, the mainnet will have validators. Recommended programming language for Moonbeam is Solidity or Ink. It is Solidity. I'm not sure if it's going to support Ink. It might, but I think we have plenty of chains supporting Ink already. There's Edgeware, there's Plasm, and you are going to have your pick in wanting to develop on Ink. In terms of Solidity, actually I think Plasm also just announced that they're going to have EVM, but the big difference is not in the execution environment in terms of the EVM. The biggest difference is in Frontier, and Frontier is this layer that's added to a substrate-based blockchain, which adds RPC endpoints from Ethereum. So when you have a tool like a wallet in Ethereum land, you connect to it through RPC calls, remote procedure calls, and these are standardized for Ethereum so that all the tools can work with any Ethereum client. Substrate does not have these RPCs. So in order to be able to behave like Ethereum, it needs to have those RPCs created for it. And those RPCs need to know how to talk to the EVM that's under the hood. That is what's happening when you have the EVM palette and the Frontier palette combined in one substrate chain. And this is what basically Moonbeam is. Ethereum's opcodes are the same on Moonbeam. Yeah, so everything is the same. They are using, I'm not 100% sure on the differences, but they're using the Ethereum classic virtual machine. But it's like the runtime is the same, the logic is the same, the code works exactly the same. You might have to do some minor alterations because we're dealing with proof of stake and not proof of work. So there are some assumptions you cannot ignore there. But in general, everything works exactly the same. The opcodes are the same. The precompiles are the same. It should all work. So we are going to be working with Moonbase Alpha, the public testnet. And this public testnet, if you go to docs Moonbeam, let me just share my screen actually. All right, so if you go to docs.moonbeam.network and then to networks testnet, you will get the RPC endpoint that you need right there on the page, and you can just connect to it. Let me zoom in here. So it's just rpc.testnet.moonbeam.network. That's the public endpoint to connect to the public testnet. We're going to be, we'll go through it. To build this raffle, we will be using a We'll be using Solidity as the programming language, so that's the de facto standard language on Ethereum. And we'll be using MetaMask as a wallet to interact with Remix. We'll also be using Remix. Remix is an in-browser editor for Solidity code. You can go to remix.ethereum.org to, let's see if I can zoom this in. All right. You can go to remix.ethereum.org to get this going, and it should open with some example contracts in the left sidebar. These are just, you know, stuff that you can immediately compile and run, and it should work. So what we're going to be doing is we will develop this locally, and we'll run the logic of this contract in the JavaScript VM. So that's the virtual machine that's running in the browser. It's like a simulation of Ethereum in the browser. We can't run the full functionality of the raffle in here, but we can use it for testing, and for testing it's good enough. Now, if you don't have MetaMask, you should probably go and install it. And I should mention that you can also run a Moonbeam node locally, and this is actually what I'm connected to when you see my MetaMask. That's why I have so much meth. I'm connected to my local version of Moonbeam, and there are instructions on in their docs on how to do that. So you have here under getting started, local node, setting up a node. The instructions are super straightforward. It takes a while for this to execute because compiling Rust programs is very, very slow. Sorry, got a little cold. It should take like 30 minutes on a decent computer. And then when you run it, you should see your node chugging along, something like this. And if I show you this, you can see that indeed my node is creating blocks. So I don't have the emojis because I'm on Windows and this doesn't really play well with whatever UTF substrate has going. But generally you can just see here that blocks are being imported into my node, and my node is chugging along. We are at block 15,000 something. So once you set up your local node, you can import a wallet which is pre-seeded with a lot of money. This is why this account has that much money. And the instructions for this are all in the docs, but we're not going to be going through that because we can't really wait 30 minutes for everybody to download and install this. We will be using the public network. So to get a public network going, make sure that you have MetaMask installed and unlocked. If you don't, just go to metamask.io and download there. So you can download it, not the mobile app, you download the extension. There you go, so supported browsers. You go to either one of these and download MetaMask. When you set up your MetaMask, you will have to remember your seed phrase. For this experiment, that's not that important. Your accounts can be discarded afterwards. Just make sure that you don't use them for anything of value in the real world, because then you won't be able to get them back. To connect to the public endpoint, you go to custom RPC and you set a network name as Moonbase Alpha. I'll put down 2 here because I already have Moonbase Alpha from before. Under RPC, you put HTTPS RPC testnet Moonbeam network. This is complaining because I already have it. I think it'll let me do things anyway. For chain ID, put down 43. This is one more than the answer to life, the universe, and everything. So 43, easy to remember. And you can put a symbol down here, whatever you want to call it. I called it meth once and dev the other times. Okay, let's put it dev. And okay, so it's not letting me because I already have this, but it'll let you save this and then you can pick it from the drop-down menu. Let's pick it here, Moonbase Alpha. If you're logged into any kind of Web3 application at the time that you do this, it's gonna refresh because it needs to become aware of your new endpoint that you are using. So I'm now connected to Moonbase Alpha. My account 1 has some dev coins because I requested them. To request the coins, you would go to their Discord. So let me just find this real quick. There you go. So this is their Discord, and there's an AlphaNet bot thing, like room here. And to get some money, you would copy, I don't know what this transaction was. To get some money, you would get your address, copy your address, and then in Discord, you would just type faucet send and then that address. And so the bot should obey. Sometimes it's bugged and takes a while longer to execute a transaction, but in general, it should work. You can also check your balance by balance and address. There you go. I got some. So now this should refresh in MetaMask, and we should be fine. We should be good to go and to start spamming the network. There we go. So we have one account. I recommend that for the purposes of testing this, what we'll be building right now, you register a few more accounts, at least 5. So I made some accounts here because we need them to add players into this raffle. That's one of the conditions. So let's make a new file. This is going to be like a crash course into Solidity as well. So this charity raffle, I built it as a tech demo to show people how to work with Solidity, some basics, and proceeds went to charity. The rewards were some conference tickets, and the raffle had the following features. It can have an arbitrary number of winners configurable by the developer. It can have a payout address settable by the developer. So if you, in our case, it went to charity, so we just put in the address of the charity. Excuse me. Anyone can call the draw function once a certain timer has elapsed, which adds a new element of gamification to it, like who's going to call it first and who will affect whose chances of winning. And also a ticket can have a variable cost. So since it was for charity, you could donate anywhere from a certain amount to a certain amount and you would get one ticket. So it's kind of like a charity raffle in real life, you know, like you would get one ticket no matter if you donated like $10 or $20 or something like that. So let's make a new file in Remix. So in Remix, in the leftmost menu, you will see the create new file option, and we can call it raffle.sol. Now every Solidity contract begins with a pragma statement, so that the compiler knows which compiler version this file was written for. So we do pragma Solidity, and then we put in a version. I like to use the recent ones, so that's going to be 0.7.1 and above. Where is my little roof? There it is. New keyboard. So this just tells the compiler that this was written for Solidity 0.7.1 and above. This is, I think, the most recent version. Every contract also, actually, let me show you here. On the side, you have a compiler, and you will choose the compiler to use here. So the newest one is 0.7.1. You should also enable auto-compile. This will automatically compile your contract as you write it and put down warnings down here. So if you make any errors, they're going to show up here and they're going to glow red on the side. So then every contract has to start with contract, and we'll give it a name. Let's call it raffle, and then we have to give it some properties. Properties are elements of a contract that will show up when you that store some values, right? And they can be public or private. You can expose them to the public so everybody can access them and read them, or you can keep them private if they're only intended to be used by the contract itself. We'll make a lot of them public so that we can inspect the progress of the contract as we play with it. So first we'll define a list of addresses, an array of addresses. That's done like so. So address and then brackets, which indicates that this is going to be a list of addresses. We'll make it public, and then we'll give it a name. Let's call it players. So this is going to store all of our player addresses. Everybody who entered into the raffle is going to be stored here. Then we'll map addresses to booleans. And what this does, let's also make this public. Let's call it unique players. What this does is it remembers, it sets a flag, true or false, for every player who entered the raffle. And so if somebody tries to enter twice, we're not going to add them to the public players list again, because we'll check that their address has already been set to true. They're already in there. You might be wondering why we don't just use the mapping and why do we need two storages? Well, because we can't really address the mapping by numeric index. So when we'll be drawing a winner, we need to pick a random number. Increase font. Yes, sir. There we go. Thank you for saying. So when we draw a winner, we will be drawing a random number. That random number has to be smaller than the number of players in the game so that we can pick a random player. If you have a number, you can't really address a value in a mapping. You can address only a value in an array. And so by doing this, we make sure that we can keep the players unique, but by doing this, we make sure we can extract one by its index from the array. So then we'll also need a list of our winners, right? And let's make that public as well. We need the winners to be public. And we will want to have a payout address to where do the funds go, right? This is just a simple address. And to be able to send money to an address, you need to declare it as payable. So it has to be payable. Again, we'll make it public so people can check where the money is going. And let's call it just payout. And we can set this to some address. I'm going to set it to like this account, whatever. So it doesn't matter. Then we have the, we should probably remember when we created this raffle so that we can say in the contract itself, do not allow this raffle to finish before some time has elapsed. So let's do that. So we'll call this UN256 creation date. And let's make that public as well so people can check when this was made. Okay, we defined some basic properties, right? So now we have the properties that we need, and that should help us get started. Now, in terms of compilation, this thing is always compiling our stuff. So it's constantly doing things. If I click compile, it just did it again. It doesn't have anything to report because we don't have any logic in there. But it's constantly checking our code. Then we can create a constructor. So every contract can, but does not need to have a constructor. And a constructor is the function that's called when the contract is created on chain. Tomasz, manually turn on 720p helps also. I'm not sure I understand what you mean. I don't have any quality options, but I am in HD mode according to Crowdcast, so hopefully you can read it. So the constructor is just the constructor, and okay, cool. And this is going to get triggered, this logic, when the contract is first created on chain. So let's do creation date, and we'll set it to block, and now you have this value timestamp. So block timestamp is the time when a block was created, when a block was mined, and this is the time it will save into creation date. To be able to play this raffle, we need to have a play function, right? So we'll do function play, and we need to have an address of a participant who is playing this raffle. We need to accept an address into this function. Any function that accepts money and Solidity contracts needs to also be declared payable. That means that you can send Ether to it. If this is not there, this flag, this attribute, then you cannot send money to to the contract as like a protection measure against stupidity. So function play, and now there are some there are some checks that we need to execute before we can go on, like some sanity checks that don't let us do illegal stuff or anybody else do illegal stuff. So the first one is that we need to require, so when you require something, anything that you put in the parentheses has to evaluate to true. If the expression is false, that means that the transaction will fail, revert, and give you the reason for the failure in the transaction output. So here we are going to put down that the message value needs to be, and I originally in the raffle I put that it has to be between 0.01 and 0.1 ether. So let's do that. So we'll put 1 ether slash 100 is bigger than 1/100th of an ether or equal to it, and we need to make sure that it's less than or equal to 1 ether slash 10. And in modern versions of Solidity, you can add a revert reason to the require. So if the transaction fails, anything you put in this string will output the error reason. So amount outside bounds, let's say. It helps to keep the messages as concise as possible, because every byte that you put into a contract will cost you more in fees when you deploy the contract. The goal is to store as little data on the chain as possible. So concise code saves money. We also need to require that the player who is entering the game, who's playing, is not already playing the game. So we are going to do that by requiring that unique players, and then we'll add here participant is false. And if he's not false, then we'll just say player already playing. Actually, let's save some bytes. Already playing. Now we have 2 sanity checks in here that are reasonably safe, and we can move on to the logic of adding a player. So we'll push a new player into it. This is just a simple array operation. So arrays have the push function, which lets you add a participant to the end of the list, or a pop function, which pops an element of the end of the list. And of course, we need to set this player's value to true, right? Because he's now a player. So now the next time this participant tries to play, his attempt will fail here, because his value in unique players will be true rather than false. That's all we need for the play function to enter a player into the raffle. Now, next we need to build a draw function so we can draw a winner. Drawing is a function, like I said, that anybody can call. So let's call it external. An external function is one that is meant to be called from outside of the contract and only outside of the contract. So no other contracts will be calling it. Users will be calling it from outside. Sorry. So we have the draw function, right? And again, we need some sanity checks here. First, we need to require that that fewer than our desired number of players have been drawn. Winners have been drawn. So if we go to winners and test the length, let's say we want a maximum of 2 winners. So let's do this, right? And 2 winners drawn already. So we need to be sure that the number of winners is less than or equal to 2. So that then we'll do a require for block timestamp. Block timestamp is equal to whatever time it is now. So whatever time we have right now has to be sufficiently after the creation date for this raffle to be valid. So let's say we want the raffle to the raffle drawing to be valid after 5 minutes of the raffle having been active. So we'll just do creation date, and actually this Solidity supports these time units that are human readable, so you can just say 5 minutes. So creation date plus 5 minutes has to be smaller than the current time in the on the blockchain. And of course we can also do this, not yet. Finally, we should probably check that we have enough players. It doesn't really make sense to draw a raffle with 2 players because they're both going to win. So let's require that the player's length is more than 4, for example. Okay. Now, the meat of the function remains. Let's get our winning player. So that's going to be, we need a number, right? A number to like, that's the index of the player in the player list, and we need a random number to pick one of those. We'll call it winning index, and so we'll get this to a function that we have yet to define, get random. We'll deal with that later. And you can see it's already flashing the red. We don't have, like, it doesn't know what get random is, and the red is here already also. It's complaining that it has no idea what get random is. So okay, we'll deal with that later. So we'll extract the winner, and the winner will be players, and we'll target that index, right? So we extracted the winner out of the winner set, and then we'll add that person to the winner array. Now that winner has been added to the winners, and automatically the length of the winners has increased by 1. Now, if we don't change anything, that same player can win again, and we don't want that. We want to disqualify one player after he's already won. So what we'll do is we'll set the player at the winning index to the last player in the remaining list. So if you imagine a list of 5 players and the second player wins, we'll just overwrite the second player with the 5th player who is in the list. So we'll just go players and then players.length -1. So this is the last one in that list. And now what we're going to do is we'll do players.pop. So now after this line, that player is in the list twice. Once in the position he just overwrote, and once at the end of the list. And so by doing this, we just pop him off the list and remove him. So he's in the list only once. And our winner no longer exists in the list of players. And finally, if this resulted in our winners array being containing the required number of winners, which is 2 in our case, then we'll just do the payout automatically. So if we have 2 winners, then we'll do payout transfer, and so the transfer function is used to transfer money to some address, but it counterintuitively works in reverse. So to transfer to payout, you call the payouts transfer function. So to transfer to address A, you call the transfer function on address A. It's a little weird, but you get used to it. And to get the balance of any address, you use the .balance modifier, but you have to convert it into an address first. So we do this, we cast this is our contract, this, and we cast it as an address, and then we take the balance of this address and send that much money to payout. Finally, let's build our get random function, right? So that we can pick the random winner at all. So we have here function get random, and we'll call this public for now, so that we can test it outside of the contract itself, outside of the interaction of the contract. View means that the function doesn't change anything on chain, therefore it is free. It does not require a transaction. And we have to specify what it returns, because it's going to be returning a number. Okay, now every random number generator, picker, has to have a seed, and a seed is like an input for it's like an entropy basis on which your random number is picked. So like if I was picking from a box of marbles, my seed is maybe the random movements of my hand, or maybe my seed is I go towards one marble with my hand and then I see a fly and it jolts me and then I pick another marble. So that's another seed. So a seed is basically some noise that you add to your randomness selection function so that you can get a random number out of it. And a seed is important in getting random numbers from computers, because if you don't have a seed, computers are deterministic. So for the same input, you will always get the same output. So if somebody can reproduce the inputs that you had while picking a random number, they can always pick the same random number, and they can also predict what random number they'll get based on some certain input in the future. This is why seeds need to be sufficiently random. In blockchains, this is very, very difficult. 1 second, I see a question. Neurocrypto. Is it safe to use block timestamp? Yes, this is exactly what I'll talk about now. So it's safe in this case. It is not safe in other cases. It is not safe when the block reward for manipulating the timestamp to get the random output that you want is less than the reward you would get for this manipulation. In this case, we're dealing with two almost worthless conference tickets. And the person to manipulate this, especially in the proof of work Ethereum, would have to have so much hash power that he would be faster than everybody else calling this function, and he would have to forsake his block reward. So he would have to discard the block reward ether that he would get and mine another block that actually achieves the results that he wants, and keep doing that until he gets the result that he wants. So the reward has to be significantly higher than the block reward for people to manipulate this. In a raffle, block timestamp is quite alright to use. Now, why is this seed important in blockchain in particular? Because blockchain nodes are computers around the world that have to agree on all kinds of input. So if if you have a one computer picking one seed and another picking one seed, computer A is going to have a different random number than computer B. Not good, because now you have a fork. You have the contract state that is different on one machine than it is on the other machine. So all of these machines also have to have the same random number in order to stay on the same fork, in order to not diverge. And so people have tried different methods of getting random numbers on chain. There's the VRF method, which is too complicated to explain right now. There are oracles that provide this, like Chainlink and so on. But yeah, essentially there are ways around this. Different chains have different methods and different like layer 2 methods and so on. In our case, block timestamp is quite alright. This is correct. Thank you. Thank you, Jamie. So, so we need to define the seed, and our seed is just going to be a very simple, very dumb thing. Just remove this. Very simple, very dumb thing that is going to be the block hash of block number, let's say -2. So we'll just get the block hash of a block 2 blocks ago, right? Unused local variable. Yeah, I know. Okay. So this is our seed. Obviously not exactly crypto safe, not exactly random, but useful for our cases, useful enough. And then we're going to return a value, and this value is going to be our calculation for the random number. So we're going to turn into an unsigned integer, so into a number, the following. So we'll put in catcheck 256. It's a hashing algo, and inside it we'll do this. This is used to kind of combine different values into one, so that you get a bunch of stuff and then you pack them into one argument, and then catcheck can process that whole all the stuff as one argument. It can hash it because catcheck doesn't take multiple arguments. So we'll encode packed the block hash of block number -1 this time, so the previous block's block hash, and we're also going to have our previously defined seed. We are also going to add, so in order to get the number that is in our range of players, we need to end up with a number that is smaller than the maximum number of players. And to do that, we just go to players.length. So the players.length modulo, so this is the modulo, this just divides the number that we get here with the number of players, and the remainder is the remainder is our random number. So this is just going to divide this by players length, and anything that's left over is going to be returned as the random number. You can see now that our contract checks out, no errors, and we can actually test it in the JavaScript VM. So we have this here. This is complaining about some sort of license identifier thing. It's just a thing that people put in comments in their code. I don't know the purpose of this. It doesn't make sense to me. So to run this code, you go to the third icon in the left menu. I don't know if you can see this, but it's the third one. It says deploy and run transactions. And you will notice that the first selector in the environment dropdown is JavaScript VM. So that's the in-browser Ethereum machine. Now we can just deploy this contract. Just click deploy. And you will see here deployed contracts. Because JavaScript VM has a bunch of accounts pre-created for you in the browser, and you can just click deploy and it'll just use those addresses. And now if you expand this deployed contract, you can see all the functions that we built. You can see them here, and they're all interactable. But since we're running a bit short on time, let's go straight to production and see if we can break it in production. So this is what we're going to do. You connect to Moonbase Alpha, like I'm connected here. Then you switch from JavaScript VM to injected Web3. This is going to trigger metamask, and for me it automatically switched. For you, it might ask you to allow this website to connect to metamask, and you should click yes, so connect to metamask. And then it's going to load the account that you want to execute transactions with. So the first thing that we're going to do is we will deploy this to the Moonbase Alpha testnet. You don't have to touch the gas limit, the value, the other stuff. None of this is necessary. You just click deploy. And now it's going to ask me to confirm this transaction. Since gas price is at 0, I'll just increase this to 5. Gas limit is fine, the estimation is fine, you just confirm this. You can see down here, creation of raffle pending. We're waiting for a block. There we go. Transaction is confirmed, and we have a deployed contract. It appeared down here. Expanding it lets us interact with it now. Now, let's see how we can play this. I have a few addresses here that I've stored before, but in general, if you have 5 accounts in your MetaMask, you should be able to copy those and just put them in here. So we'll put them into play field. And the field in play is this argument here that we defined in code. So we put the address in here, but clicking play is not going to be enough. We need to add some ether. So we need to add either something between 0.01 and 0.1. So let's say 0.05. Make sure you change to ether. So the unit has to change to ether. Now we can play. And so you'll notice that we don't actually have to call this function from the participant address. Anybody can register anybody else as a player. That's the way we define the function. We could have limited it to participant only, but where's the fun in that? So again, gas price 0, let's up it to 5, and you'll see an estimation here. Let's see. Now our player is being added to the players list. Transaction confirmed. And now if we click on players, this field will default to 0. So it means show me the 0th index of the players array. In other words, show me the first entry in this array, the first address in this array. And sure enough, our player is in there. If we look at 1, that's the second entry, we get an error because there's nothing there. So let's add 4 more of these players in there real quick. Again, 0.05. 5. All right. There's another one. All right. One more. 0.5. Play. Whoops, I didn't modify the gas price. Let's see if that goes through. Oh, it went through. Okay. Oh. .05. Play. Add another one. Okay, Alberto, thanks. Gas price is set to 0 in the testnet, so we should actually be able to always use 0. There we go, 0 and okay. Whoops, this is gonna fail because I set 0 ether. Okay, let's change this to 0.5. I'm not sure why it's still trying. Let's check in metamask. Activity, play, still pending. Alright, let's cancel this transaction. There we go. Failed. Alright, and now let's replay it for 0.05 ETH. That's right. Oops. Okay, so now we should have 5 players in there. We'll check that out now. Okay, so number 1, there we go. 2, 3, and 4. 5 gives an error. There you go. So we have 4 players now in the game. We can also click the payout button to check out the payout address, and we can also click the get random button to see who would win if we called this function right now. So get random, the second player would win. So this is always, arrays start counting at 0, so this is the second player. If we wait for a new block, because we know that the random function is influenced by the block numbers, click again, there we go, the last player would win. So this is for testing our get random function. A raffle in production would not have this as public. It would in fact have this as an internal function so that only the contract can use it. Another one, this is the first player, is the winner. Now, this looks clumsy in terms of UI. Remix is not the best in user experience, but I have a nice trick here that you can use, and that's one-click DApp. That's wonderful. So one-click DApp is a tool that lets you build a UI for your DApp, for your decentralized application, like this raffle, in a single click. First, you enter a name here. Let's say raffle. Enter. Now it asks us for an address and for a network. And then we need to provide an ABI. An ABI is an interface through which is kind of like a recipe for a UI to understand which functions exist in a contract. Because a contract is deployed online on a chain in binary format, it doesn't really, if you inspect it, you just see gibberish. You don't see the functions and names and so on. So you need this ABI as a kind of a translation layer between the UI and the chain. So let's fill that out. Our contract's address is actually on the side here, which can just click copy, and we have the address. The network we can set as private. Let's say private. I'm not sure this is actually going to work now. It worked with the local thing when I was running a local node, but I'm not sure it can work with a fully custom. It should work. Let's see. And let's provide it with the ABI. So the ABI you can find, I think it's here. No. It's here. There we go, ABI. So under, that's in the second tab, in the compiler section. Under your contract, you will see, under compilation details, you will see the ABI and the bytecode. So we need the ABI. Just click on it, it'll get copied into your clipboard, and then paste it in here. Scroll through to check that's really it. Yeah, unique players is here. That's definitely our contract. Let's see now. Create that. Mainnet unknown. Let's see. Yep, that looks like it might be it. Or 23,284. Let me just really quickly check something out here. There we go. So we have this, there's this explorer here, expedition.dev. I'll put it in the chat. So this explorer lets you explore any custom Ethereum blockchain. And if we check what the public testnet is at in terms of block height, it's 23,288. If I check my one-click tap, it is indeed that block. So 23,284, 23,288. It did connect to our thing. So now you see we have here an auto-created user interface for all of our functions. We have the play, which lets us add the address and the value to send, and arguably a little nicer UI than in Remix. And we have the read data. So if we click on any of these, payout, check, it tells me the, it should tell me the address. It's not telling me the address right now. There we go. So it read the address, creation date, check. I'm not sure why it's that slow. It's like it's lagging or something, waiting for a block. Yeah, it's like it's having trouble keeping up with the RPC endpoint. That's probably because it's going through metamask and not directly. So there we go, it appeared. Granted, not the ideal UX if it's that slow. Oh well. Okay, so then let's finish this in the remix. But basically, what I wanted to say is that this contract is deployed and live on the Moonbase alpha testnet. It works. The raffle is live on an Ethereum clone, and we can interact with it. It's just Solidity code. We can add players into it, and we can draw some winners. And in fact, if you check out, I think the Explorer should support this. Let's check this out. If we search for the address, and this is a little slow too. There we go. So you can see here that we have a balance of 0.25, and that's because we added 5 players at 0.05 each. And that's correct. We have the bytecode here. So this is the code that I was talking about. Your UI cannot understand what this means. So this is why you give it the ABI, so that it can translate this into a user interface that you can understand. So let's try and draw some winners. Let's hope this works. Let's go to Remix. And now anybody can call a draw. Since it's been 5 minutes since we deployed this, probably, we can just call the draw function. Now in this case, the gas estimator isn't really doing that great a job at. Let me just kill my local node. Maybe that's slowing things down. The gas estimator isn't that good, so you need to do some manual tweaking there. I'll show you how if this ever gets started. I don't know what's up. Injected Web3, custom 43. Transact to the raffle drop pending. So why didn't... This looks like a metamask problem because it didn't ask me to confirm anything. Okay, let's copy the address and let's refresh. When you copy the address of a contract, you can reload it as deployed into Remix. So you open the raffle contract. Then we'll go into the test and deploy, and then you'll see here load contract from address. But we need to switch to injected Web3 first. We did that. That's my account. Something is strange though. It doesn't tell me the balance. Add contract, so we'll load it. Add address. There we go. There it is. And if we check the players, it's really, really slow. I don't know what's up with MetaMask now. Or maybe it's the RPC endpoint of the testnet, since the expedition was slow as well and the raffle UI was slow. Okay, while I try to get this to work on my local node so that I don't leave you hanging, feel free to put some questions into the ask a question box and I'll get to those ASAP. In the meanwhile, I'll try to redeploy this on my local node. So first I'm going to switch to my local endpoint, that's Moonbeam, on my computer. Then I'm going to deploy the raffle contract. There we go, this is much faster. Okay, let's speed it up, I guess. Not sure why it's not letting me now. Consensus hash, alright. Seems alright, but it's not letting the transaction through. This loaded, that's fine. No, sorry, looks like my metamask failed or something. Why is this now? Or, wait. Yeah, sorry about that. I guess the gods of live demos weren't happy today, so that's the price of doing it this way. Anyway, I'm gonna put up a written tutorial of all this online so you can follow along and do this on your own. But I do hope that it was useful and that you followed along for as much as you could in exploring this. I will try and find out why MetaMask is failing here so much, and I'll put a note in the tutorial so that you can avoid this. This hasn't happened before. Anyway, we're out of time. If there are any other questions, please feel free to get in touch via Riot or email. So it's just bruno@web3.foundation. And be sure to check out Moonbeam. So go to moonbeam.network, and I hope I'll see you there. We have a question. What is the difference between Plasm and Moonbeam? I don't know because I haven't used Plasm. I do think Plasm doesn't integrate Frontier, so they don't have the RPCs for Ethereum, but I could be wrong, so I'm not sure. Either way, even if they have the exact same feature set, competition is good, right? So let's hope that they have an awesome product that we can also play as easily with as this, and you know, deploy some awesome things on Substrate's Ethereum. Okay, thanks all. See you in the next one. Bye.